Welcome back. So today we're going to continue our discussion on implicit differentiation, and I want to focus today on equations of tangent lines. So we've found equations of tangent lines, and we've also found derivatives with implicit differentiation. So we're going to kind of put those two topics together. Recall the equation of a tangent line is y minus y1 equals m times x minus x1, where y1 and x1 are our points from our given, and m is our slope that comes from the derivative at the given x value. So in our example, we have x squared plus y squared equals 5. Recall this is the equation of a circle. We're going to go ahead and find, when x equals 1, the equation of the tangent line. So if I were to sketch this out fairly quickly, and it's going to be centered at the origin, when x equals 1, we'll call 1 here maybe, so it's going to be the tangent line there, but we're also going to have a value down here. So we're going to see that we have two equations that we're going to have to work with. So our derivative is probably going to have two values. So we want to do, 1, find the derivative, and 2, find our points. So we can do either one at any point in time, doesn't matter. If I go ahead and plug in 1 for x, I have 1 plus y squared equals 5. So y squared will equal 4. So y is going to equal plus or minus 2. And hopefully that kind of makes sense to us, since we're centered on the origin, that our points, we'd have one point at 1, 2, and have another point at 1, negative 2. Now we need to go ahead and find our slope. What we're going to do is go ahead and plug in, or find our derivative implicitly. Derivative of x squared is 2x. Derivative of y squared is 2y. Remember to put the dy dx with that. Equals derivative of 5 is 0. Again, cautious, very cautious that the derivative of a constant is 0. Make sure you take the derivative of that right side. Go ahead and solve for our dy dx. And we get dy dx is going to equal negative x over y. Subtract your 2x and then divide by 2y. So now I got my 2 points. I have my slope in terms of x and y. I can go ahead now and find the slope with those points. So dy dx, I'm going to go ahead and label this as 0.12, is going to equal my negative 1 over 2. And hopefully that makes sense to us, since we're looking at this 0.12. That slope should be a negative value. It is coming down in the downward direction. So that's going to be our slope. So that equation then at that point and that slope is going to be y minus 2 equals negative 1/2 times x minus 1. Likewise, I can do the same thing for my second point. So dy dx at the point 1, negative 2 is going to equal negative 1 divided by my y value, which is negative 2, or 1/2. Again, that hopefully makes sense to us as well, since we have a positive slope when we drew out that circle. So our equation here is going to be y minus, or y plus 2, y minus a negative 2, equals a positive 1/2 times x minus 1. And that's going to be the two equations that we have. Notice we had two tangent lines, we're going to have two equations as well. Kind of a fun thing that we could do, maybe an extra credit question somewhere along the line, would be to make these two lines intersect and then find that point of intersection. Anyway, we go back to our problems, our examples. Here, we have x squared minus y squared equals 16. Again, we're just given an x value, so we've got to come up with that y value. So I plug in 2 for my x. I have 4 minus y squared is going to equal 16. So a negative y squared is going to equal 12. So y squared will equal a negative 12. If we take the square root of that, then we know that y equals the square root of negative 12, which, hey, that can't happen. We've got issues, don't we? So what we have is this doesn't really exist. It's not going to work for us. So maybe we should go ahead and change this problem. Didn't realize it wasn't going to work for us. What if we gave you x squared minus y squared equals, how about if we make it negative 16? Maybe this will work for us. So now if x equals 2, if I plug in 2, I get 4 minus y squared equals a negative 16. So negative y squared equals a negative 20. I got one that's going to work. Apologies for that. So y equals plus or minus the square root of 20. If you want to reduce that, we could do plus or minus 2 radical 5. Again, remember we can't take the square root of a negative number up here, so if this were our answer or problem, then we would just say there is no equation of a tangent line. When x equals 2, because x equals 2, it doesn't exist, does it? So we made up a problem that would make sense, so we can go ahead and work through that. So we get y equals plus or minus 2 radical 5. So we have our points, 2, 2 radical 5, and 2, negative 2 radical 5, for the sake of being able to do a problem. Go ahead and find our derivative. So we have 2x minus 2y dy dx, and that's going to equal 0. Go ahead and subtract your x, or 2x, divide by your negative 2y, so dy dx will equal x over y. Again, we can go ahead and then find at our points. So dy dx at the point 2 radical 5 will be 2 divided by 2 radical 5, or 1 over radical 5. Some professors, some teachers want you to rationalize that. Personally, it doesn't matter to me. If it's multiple choice test or quiz, you're going to see that rationalized. So I'll go ahead and rationalize it, and we get radical 5 over 5. So the slope that goes with the point 2 radical 5 is radical 5 over 5, so we can write that equation. Y minus 2 radical 5 is going to equal radical 5 over 5 times x minus 2. We can go ahead and do our second point, dy dx, at 2, negative 2 radical 5. So that slope is going to be 2 divided by negative 2 radical 5, which will reduce to negative 1 over radical 5. Again, rationalize, we get negative radical 5 over 5. So the equation here is going to be y plus 2 radical 5 is going to equal negative radical 5 over 5 times x minus 2. And that gives you an idea of being able to find the equation of tangent lines using implicit differentiation. Good luck, have fun, and enjoy.